Hi, welcome to the final part of our Padauk 3-cent microcontroller programming series, where we build up some open source hardware and software to program these 3-cent microcontrollers. Now, in part 4, we took a look at actually using the SDC C compiler, the small device C compiler, to actually program a file and generate an Intel hex file, which then we can use on our programmer to program our little chip. So we're basically just taking an existing pre-written example file and compiling it, generating the Intel hex file, and then simply running the command line programmer to program that Intel hex file into our chip. Sounds easy, but you guessed it, Murphy. Yeah, this is going to be a pain in the ass. You'd be amazed at what can go wrong with just doing that. Let's check it out. And there it is. I didn't bother with any of that bypass capacitor rubbish. Don't need that. And yes, I'm going to say it. Winner, winner, chicken dinner. Of course it works. And I have no doubt that actually says hello world if we actually go in there and single shot capture that. And what? Oh, does it? Oh, that looks very clock-like to me. Actually, that doesn't look like a hello world. Oh, have we come a gutser? It's outputting something. Oops, dumbass Dave. Eagle-eyed viewers will no doubt see that I probed the wrong damn pin. There we go. Oh, hang on. Does it need a pull-up? Aha, that looks better. I think we have a dodgy connection issue because it's all over the shop. Anyway, yeah, that's actually probing though. That's actually not probing the bit 0. So, pin 0 or whatever. So that's probing 1 over. So, yeah. Anyway, that's the one that I get the signal out on. Wow. Check this out. Yes, I had to swap our scopes to this brand new Siglent 2000X Plus series because my little Keysight 1000, I didn't have the serial license, so I couldn't, do any serial decoding. So I've switched. Anyway, watch this. Watch this. This is really weird. Now, like you think, okay, we're getting data out. It's not on the correct A. It's not on the correct pin we expect. But watch this. Watch this. If I put my hand near it, oh, look. Magic voodoo. Ooh, spooky action at a distance. I'm not kidding. Like this, and if I put my finger on the probe, look, if I touch it very lightly and if I touch it harder, I can make it completely vanish. Wow, look at that. So that's the pin that we're supposed to be getting out, and we're not. We're just getting some crusty stuff on the ground there. So it's that pin there, which is pin 6. And pin 5, we're getting something as well. Just realised that. Pin 5 seems... No, but look, if I hold my fingers on there, take them off, this is literally spooky action at a distance. Yes, I've put a bypass cap on there. I've checked the connections and everything else. So when you start seeing weird stuff like this happening, right? There we go. There's our packets. When you start seeing weird stuff like this happening, and like spooky action at a distance, you have to assume that there's some sort of floating input happening, and it's of course picking up like the 50 hertz from my fingers, right? As I get close, there's capacitive coupling through the air into the pins. Now, of course, this thing doesn't use... Oh, there we go. I can make it die completely. These things, it doesn't have, you saw the code doesn't have any input whatsoever. It's supposed to be using internal oscillator and then simply outputting data. But those keen-eyed might have seen that in the code before that this actually works on interrupts. So that's what I'm thinking, is that it's got the wrong chip target in there, because I believe the code was for the PMS 154. We've got the 154C, and I'm wondering if that makes a difference. So anyway, we'll look into the code in a minute, but yeah, when you start seeing spooky action at a distance like that, something's floating. So what I'm going to do is just ground some of the inputs, because they're all floating at the moment, and see if that makes a difference. I just tied pin 2 high here, and that's already killed the output. So yeah, something's going on. Let me just lift that. Oh, whoa, whoa. This is weird stuff. Nah, hang on. I'll lift it. Okay, there it is. Let me touch that. Yeah, look at that. I can change that just by touching that input. Wow. And by the way, this is 0 to 5 volts. These are real, genuine totem pole driven, hard, outputs. These aren't, this micro's not mucking around. It's actually genuinely driving those output signals hard. So it's not just the output flapping around in the breeze. Something's causing, my guess would be something's causing the input. There's some input somewhere because the chip's configured wrong somehow. It's goofed it up because, I don't know, might have the wrong chip type or whatever, and the configuration registers were different or something, and it's just configured it oddbally to have some sort of an input which might have an effect on the interrupt routine that's, sending the output data. Oh, look at this. The PFS 154. The PFC. No, I've got the PMS. Oh, it's like all these confusing numberings and things like that. I mean, PMC 154. Can you even buy that? Is it a thing? No. Is it on the Padauk website? PMC. There it is. We've got different types. The PMC 153, 156. The PMC 154 is not even there. Like, it's just, anyway. So I would imagine that, because look, they've got different, they've got if defs in here, right? If define, if it's the PMS 173, if it's the PFS 154, the PFC, that's why we've come a guts, because it has different register addresses for all this sort of stuff. So it's a wonder it works at all. So it looks like there are subtle differences between all the modules, and I would imagine that the PMS is different as well. And we could go in there and search all the register entries and stuff like that and try and fix this up. So I think I'm better off just going over and finding some other code like this one. Does this one work? Here we go. I found like a blinky thing with the timer. Does it say anything about timer IRQ blink? This one actually doesn't say anything. This one just says, right, so here's the original mini-C code, they call it, which is, I guess, Padauk C. And they've commented all that out, and here is the new code. But it doesn't say which one this is actually will compile for. But hey, it takes me like a minute to compile this and program a new chip. And I've got lots of chips, even though they're one-time programmable. I've got a few. So, yeah, we can afford to do this. And that's the thing. Like, even though these aren't flash, you can still, like, these are so cheap. They're 3 cents a pop. So you can actually afford, I know it's like a waste, but you can actually afford to refine your code like this. And once you get it perfect, and just go through, even if you have to go through 50 of these things to perfect your code, once you do, bingo, it's set in stone, because these programs aren't big. They're pretty easy to test and actually refine and get working absolutely perfectly and thoroughly. So that, yeah, you can be confident that you can program these one-time chips once your program's all debugged and stuff like that. Or you can buy the emulator and use the emulator and stuff like that if you really want to do that. But anyway, yeah, at 3 cents a pop, I wouldn't be complaining about burning through a few of these, literally. You're a week. Now, interestingly, on the EEVblog forum post over here, I found an extra programming option here, DPFS154, or PMS15C, and I actually just tried that, compiling this, adding that option in, and it does actually work. It didn't recognize lowercase, as you can see, but so maybe I could recompile the other one with that DPMS154C option and see if that works. That'd be an interesting test. So anyway, I thought I'd just redo that project. I goofed it. I did text again. Test. There we go. So it actually compiles that. So now if I go test.c and test.rel and then you really need a script to do this stuff. You know, like a program, someone can do like a simple program that just puts all these options in you, like checkbox, I've got this chip, and it automatically knows it's a 14-bit architecture and it puts in the option for that and stuff like that. So anyway, test.rel, test.ihex, boom. Okay, so I now have a new test.ihx. Yep, okay, so I'm going to program. PMS154C write test.ihex. Okay, I got my chip in. I should have probed it first. PMS154C write. Done. Ha! Let's try that. No, that was worth a shot, but it's doing the same voodoo thing, so yeah, that didn't make a difference. It's the code. Anyway, what I'm going to do is this interrupt-driven LED blinky program over here, which is for a mysterious chip. Never know your luck in the big city, so let's try that. I've got that saved as test 2 and PMS154 device. Boom. Test 2 rel. Test 2 Intel hex. Boom. And if you're wondering why I've changed my t-shirt, it's not because I've come back later or the day later, because I'm filming this over multiple days. It's because the other one I was wearing was just generating too much static and I didn't want to be like I don't want to have to ESD strap. So yeah. Right, test 2. Done. This is too easy. Winner, winner, chicken dinner. And let's see if there's any funny business going on here. This is just like doing like a 1 second thing. What's the time base there? 500 milliseconds per division, yeah. And no, it's still doing it. I don't know how to get roll mode on this thing. It's just acquiring and then it's got to update the screen. This seems to work fine. And if I do the other pins, nope. I only get... whoop, there we go, I just disconnected. I only get that, so that works. So yeah, if we want to get the Hello World thing working, I think we have to go in and figure out what registers are wrong there and like, you know, what what's actually up with that. So that could require debugging. I'm not sure I'll do that. Would have liked to have seen like a UART output with Hello World. We almost got it there, but it's just some silly bugger business going on. Anyway, there you go. Dumbass Dave didn't see the roll button over here. There you go. So that's our, and if we probe the other pins, you can see we get zippity doodah, because that's actually not an output, so we're actually picking up crap there. So yeah, if I touch that, we're picking up my 50 hertz there. So yeah, they're configured as inputs, not as outputs. Only pin 7 there is configured as the output. So we're getting our like 1 hertz signal, and that comes from an internal interrupt using like timer-based interrupt divided by the main internal clock. Fantastic. So there you go. We proved that we can program a chip, no worries. Wah, 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 wah. Be careful pulling these out of your breadboards. There's the spring. Where's my other spring down there? Oops. Kamagata. Alright, so I just might have a quick look in header format here. Register mapping, scroll right. Don't know what that is, but programmer notes. Ooh, special code found in PMS154B. Oh, I've only got the C. I want the special. Aha, register mapping. Here we go. This is what I want. 154, PFS 154. There you go. So we should be able to PMS 150C. I assume it's the same for the 154. Is it the same? Scroll. Yeah, that's why it said scroll. Right. Yes, because you got to scroll across. 15. Has it got the other ones? 154. PMS 15. PFS 154. PMS 152. Yeah, so I think the 150, this is the one we want. I think the PMS 150C, because we've got the C version. So I think all the ones, they're just like different size pinouts and stuff. So the internal registers should be the same. So our program, our code over here is written for this PFS 154. Here it is, PFS 154. So we have to modify anything that's related to the PFS 154, change it to whatever we can get to the equivalent one for the 150C. And hopefully we can get our program working, because yeah, what's actually causing that weird ass fault? I can only imagine it's getting an interrupt from an input pin, a floating input pin somehow. Well, no, I'm actually comparing all this stuff here between the PMS and the PFS 154, and they're all the same. Like the port A register, the port A control, which is the pack register, all the interrupt stuff, interrupt requests, the timer is all the same. They're all the same address. So, like, and we're not calling up PDK 15, so it should give the else. I guess I could simply take out that code just in case it's doing something weird and only have that, perhaps, if I get desperate, but that should work. Apart from that, I don't know what, like register, like what bit operations are happening here. I haven't gone that far in, but if we've got the right registers, they should operate in the same way across all of the different devices. You know, like the interrupt register should have the same bits in it for all the different devices. It's just a different address that the interrupt register might be at. I don't get it. Factory calibration. I mean, the timer seems to be working and everything seems to be doing the business, but very strange. Very strange. Port A control. There's the, you know, the bit that we're turning on. I don't even see that actually working properly. So maybe I can just make them all outputs or something like that. Make them all outputs, see if that makes a difference. So yeah, I am not seeing it based on that register. So I don't know. Maybe people are screaming at me in the comments going, "Oh, Dave, it's obvious," but I'm not seeing it. No, I was hoping I could just modify some registers, but no. Anyway, I might have muck around, but yeah, if I don't update you on this, it means that my muck arounds weren't successful. And nope, unfortunately, taking out all that stuff didn't work. It does exactly the same thing. So I have no idea what's going on there. I could spend ages trying to troubleshoot this. But anyway, that's not really the point of this video. The point of this whole video series was to show you how to take a GitHub project that you might need for some particular purpose and actually order all the parts, order the board, assemble it, and then test it, get it working, potentially debug it, and then get all of the software actually working. All this open source programmer software wasn't as trivial as I thought it might be. And we ran into a few interesting hurdles there that we had to overcome. So I really like it when that sort of thing happens. So anyway, if you like that video, please give it a big thumbs up. And as always, comment down below. And I especially want to hear about this format. I did ask this of my supporters. I took a poll, and the majority of people said, yeah, they want to see this sort of like longer form, like follow along with Dave as Dave goes through and bumbles his way through, because like the whole process, rather than just some, you know, spit and polish tutorial where nothing goes wrong. Sure, I could edit this thing till the cows come home to produce like a single 10-minute video of here's how to, you know, get the Padauk software actually working and the hardware and software working from the go. And if you want that, please leave it in the comments down below. Maybe I can take this existing multi-part tutorial and actually condense it down to a more manageable 10-15 minute type instructional video. But let us know what you think about the, you know, follow along as things go wrong and we have to troubleshoot and we have to bumble around and figure out this problem and solve that problem and things like that. So yeah, in the comments down below. And of course, yes, I'm going to shout out my library channel. I think I'm at 20,000 subs. I was like 990 something. So by the time this video comes out, I'm sure I'm over 20,000, which is absolutely fantastic. And of course, I rarely mention, but I've got a Patreon as well, where you can often get early access to videos. I actually release them early, including this particular series as well. So if you want my early stuff, head on over to Patreon. I'm having a bit of trouble with my Discord server as well. And also I have other channels. I still have my BitChute channel. I still upload my videos on Vimeo. I batch upload and other places. Heck, I still even have my RSS feed from day one, which is a 720p one hosted directly on my own web server as well. So yeah, anyway, that was good fun. I enjoyed that process. It took a little while, but we got there. You know, I expected a few hurdles. I was hoping for a few hurdles and we got it. Beauty. Anyway, hope you enjoyed it and found it useful. Catch you next time.